Okay, so this is the problem from section 9.2. The sides of a nuclear power plant cooling tower form a hyperbola. The diameter of the bottom of the tower is 304 feet. The smallest diameter of the tower is 186 feet, which is 441 feet above the ground. The tower is 596 feet tall. Find the width of the tower at a height of 22 feet to one decimal place. To do this problem, first of all, you have to know the standard equation for hyperbola. So let me just do it here. So let's try to draw a hyperbola using the coordinate system. So the coordinate system is, you need to draw x-axis and y-axis. So let's say your hyperbola, the center of your hyperbola is at the origin. So this is the origin. Okay. So this is the hyperbola. My hyperbola is not perfect, but you can make it, the hyperbola with center at origin. So let me just redraw this. Okay. And this is the bottom part, this is the top part, and here is the origin. And in this problem, we have given that, this is, if you just read the problem, it says the smallest diameter of the tower is 186. That should be on, this line. This is called transverse axis. Okay. So the equation of hyperbola center at origin is x square over a square minus y square over b square equal 1. And the distance from here to here, which is smallest diameter, is 2a. So the value of a is the smallest diameter. You can see here from here to here. This would be the smallest diameter. And it's given, the smallest diameter is given, it's 186. So that is actually the value of 2a, because from here to here that's a, and from here to here that's another a. So 2a is 186. So you can find the value of a from here. Now you can see that in this picture here, this is 441 feet down. So from this point to the downer part, this point here, that is 441. So if you try to find out the point on hyperbola itself, this would be the x coordinate. We need to find out that x coordinate, and the y coordinate, you can see that it's 441 down. It's a negative 441. And for the x coordinate, you can find the x coordinate by how do you find it? You need to yeah, you can find it. Okay, so let's go further and let's see. We have given a. We need to pick x coordinate and y coordinate from this hyperbola, such that we can plug those value of x and y here and find and we can find the value of b. Okay, so for that, what we can do is because the diameter of this bottom part, it's also given, it's 304. So the diameter of the bottom part is 304. That means from this point to this point, that's a 304. So half of it gives you the value of x coordinate here, which is 304 divided by 2 is 152. So the x coordinate here would be 152. So let me just erase that x here, which is 152. And let me change the color here. So this is 152. I got the x coordinate by finding the half of this diameter of this bottom part, and then I got the y coordinate by finding the distance from the smallest diameter to the bottom part, which is 441. If it's a center at origin, then that would be the uh, negative of that is your y coordinate. So now we have x one point on the on this hyperbola. We have the value of a from here, which is a equal 186 divided by 2 is 393. So now we're going to plug value of a, x and y here to find out the value of b. So that will give you all the requirement thing we need for this hyperbola. So if you try to simplify this, it will be actually y square equal b square equal x square over a square minus 1. So if you try to find the value of b, this is b square equal y square over x square over a square minus 1. That's how we can find the b. So in this case, if we put y is equal to, as you can see that is 441 square, and x is you can see that it's 151, because there the y is negative, but we don't care about the negative because there is a square of that number, and x is 152 square, a square is 93 square minus 1. So that's the value of b square. That's the value of b square. So if you try to find out the b, you just have to find out the square root of this number. Square root of this number. Okay, so that's b. Now in this problem we need to find the width of the tower at a height of 22 feet to 1 decimal place. So from origin, if you go to the 22 feet, because origin no, at a height of 22 feet. So this is the the ground part. This is bottom part is the starting point. So if you go 22 feet above the ground, 22 feet above the ground, which is 441 minus 22, that means you can find the distance from that, the distance of that point from the origin would be so that's 441 minus 22, that is actually 419. So so if you go 419 feet down from the origin, that will give you a point. So this is the point, which is 419 from the origin, but from the ground it is 22 feet. So at this point we need to find out the width. Width means we need to find out the distance, this diameter. We need to find out the distance from here to here and here to here. That gives you the width of this hyperbola. That's the width of hyperbola at 22 feet from the ground and 419 feet from the origin. So at this point, as you can see that at this point we know the y value is negative 419. We don't know what is x, so that is what we need to find. After finding the x, just make it double, and that will be the width of this slice of this hyperbola. And for that we're going to use the very same equation, this is standard equation for finding the x. And now you can use the very same equation, x square over a square minus y square over b square equal 1. So x square is equal to a square 1 plus y square over b square. This time keep in mind your value of a and b, you already found the value of a and b from here. We already have the b square, we already have the a square, and we already have, at this point we already have y, which is 419. Make sure that it's 19, okay, negative 419. So if I'm going to plug this value here, so a square is 93 square, y square is 419 square. You don't care about the negative sign because it's a square, and b square is coming from this value here, this value. B square is this value, so which is 441 square over, me just make it smaller so that I can see it. 441 square over 152 square 93 square 152 square 93 square minus 1 divide. So that will give us x square. So if you want to find out the x, you just have to take the square root of this value. So here I'm going to use the Wolfram alpha to type this and calculate this value. So square root 93 square parenthesis 1 plus 492 square divide by this expression. So let me just make it smaller here. So square root and then 93 square. You just have to use a calculator. I'm using Wolfram alpha here to calculate this value. 1 plus 419 square 419 square divided by parenthesis 441 square divided by another parenthesis 152 square divided by 93 square minus 1 parenthesis close, another parenthesis close, and do I have okay another one, and let's calculate this. Okay, look at here, 93 square 1 plus 419 square 441 square divided by 152 square 93 square. So that is what we are trying to find out. 93 square 1 plus 419 square divided by 441 square parenthesis 152 square 93 square minus 1. So the value is, you can see it's a 147.30. So because that's the value of x, so that's just the half of the width. This is just the one part of the width. So if you want to find out the width, you just have to multiply that by 2. So this value is approximately 147.30, and width is actually 2 times this value. So 2 times this is you can find out this value. 2 times this 294.60 feet. So I'm going to plug this value back here, 294.6. That's a 1 decimal place, and that's right. Okay.